So hello everyone. So today's topic is principle of mathematical induction. Principle of mathematical induction. So principle of mathematical induction is based on two types of reasoning: deductive reasoning and inductive reasoning. So deductive reasoning is the application of general case to a particular case. It is the application of general case to a particular case, where proofs may or may not be established, may or may not be established. For example, statement 1 is Socrates is a man, and statement B is all men are mortal. All men are mortal. So statement C can be Socrates is moral. So if statement A and B are true, if A and B are true, then the truth of statement C is established. Then truth of statement C is established. So this is deductive reasoning. Based on two statements, we deduce the third statement that Socrates is moral. So this is deductive reasoning. Second is inductive reasoning. Inductive reasoning is means it means generalization from particular case to general case. So it is a key concept in scientific reasoning where collecting and analyzing data is the norm. It is a key aspect of scientific reasoning where collecting and analyzing data is the norm. Where collecting and analyzing data is the norm. So our topic is principle of mathematical induction, which is based on inductive reasoning. Which is based on inductive reasoning. So what is principle of mathematical induction? what is principle of mathematical induction? So it is used to prove mathematical results. So this principle is used to prove mathematical results. Principle is used to prove mathematical results. So suppose there is a given statement Pn involving natural number n, involving natural number n, such that the statement is true for n equal to 1. The statement true for n equal to 1, that is P1 is true. Second statement, if the statement is true for n equal to k, then statement is also true for n equal to k plus 1. If the statement is true for n equal to k, then statement is also true for n equal to k plus 1, is also true for n equal to k plus 1. That is, the truth of pk implies the truth of pk plus 1. That is, the truth of pk plus 1 implies the truth of pk plus 1. So for example, we have Pn is equal to 1 plus 3 plus 5 plus 7 to n minus 1 is equal to n square. So it is a sum of odd natural numbers. Sum of odd natural numbers. We have to find that it is true for every value of n. So step 1, put n equal to 1. So P1 is equal to 1 square equal to 1. Therefore LHS equal to RHS equal to 1. Hence P1 is true. So step 2, substitute n equal to k. So Pk is equal to 1 plus 3 plus 5 plus 7 dot 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 2k minus 1 is equal to k square. So first step, this step is inductive step. So we need to prove from step 2. So from here we need to prove that pk plus 1 is also true. pk plus 1 is also true. So let's take pk is equal to 1 plus 3 plus 5, 2k plus 1, and add and subtract the following mathematical number: 2k plus 1 minus 1 and 2k plus 1 minus 1 is equal to k square. So we can write 2 1 plus 3 plus 5, and this will become 2k plus 1 minus 1, and this will goes to this side. So k square plus 2 k plus 1 minus 1. So 1 plus 3 plus 5, 2 k plus 1 minus 1 is equal to k square plus 2k plus 2 minus 1. So we can simplify k square plus 2k plus 1 is equal to k plus 1 square. So pk plus 1 is true. So pk plus 1 is true when pk is true. Therefore Pn is true for any number. Pn is true for any natural number. Second is, let's take another example. Example 2. We have to prove 2n is greater than n. So step 1 is inductive step. Step 1 is inductive step. Put n equal to 1. So 2, 1. So this implies 2 is greater than 1, which is true. Therefore P1 is true. Now step 2. Put n equal to k. So pk is 2k greater than k. Now step 3. So if pk is true, then we have to prove whether pk plus 1 is also true. So take this equation 1 from 1, pk is equal to 2k greater than k. So multiply both sides by 2. So pk is equal to 2k dot 2 greater than 2k. So this implies 2k plus 1 is greater than k plus k. So 2k plus 1. So k plus 1, k plus k is greater than k plus 1. Hence we can write 2k plus 1 is greater than k plus 1. So if pk is true, which implies p k plus 1 is true. Therefore 2n greater than n is true for all value of n. Is true for all value of n. So now we take another example. To prove AB is equal to AN BN. So first step is inductive step. Step 1 is the inductive step. Put n equal to 1. So P1 is AB, 1 is equal to A1, B1 is equal to, which implies AB is equal to AB. Therefore P1 is true. Step 2, put n equal to k. Therefore AB, k is equal to A, k, B, k. So now step 3, we need to prove pk plus 1 is true if pk is true. So we know pk is true, which therefore AB is equal to AK BK. So multiply both side by AB to make it k plus 1 on left hand side. Multiply both side by k by AB. So AB k AB is equal to AK BK into AB. So we can write this as AB k plus 1, and we can write AK dot BK dot A dot B. So rearrange the term. A A will be AK plus 1 and BK plus 1. Therefore AB k plus 1 is equal to A k plus 1 and B k plus 1. So P k plus 1 is true if Pk is true. Therefore Pn is true for all natural numbers. Pn is true for any natural number. So this is the topic about principle of mathematical induction. Thank you.